Hey, this is Mr. Ward, and this is the Algebra Do Now 29.2 video key. And here we go. So x squared minus 25 could be expressed as x squared plus 0x minus 25. So what are two factors of negative 25 that add up to 0? Well, a useful tool is to make one of these. Make a little x like this. Okay, and we'll put a dot for multiplication, and we'll say negative 25 because we're looking for two things that multiply to get a product of 25, but we're going to put a plus down here because we're also looking for a sum of 0 from those two things. So we want to think about two factors of negative 25. One will be negative and one will be positive, and they will be negative 5 and 5. Because 5 plus negative 5 equals 0, and 5 times negative 5 equals negative 25. And then, of course, we can just put an x here and an x here. And now you've got two linear factors right there. That's a linear factor. That's a linear factor. Linear binomials because they got 1, 2 terms in them. And there you have it. So the two factors would be negative 5 and 5. Okay, now we're going to multiply out. This is also known as expanding. Oh, x plus 5 times x minus 5. That's the same thing as this, just in a different order. Well, so it seems like those might match up, and let's make sure. Let's prove it. So I'm going to start off by doing x times x, so x squared. Then I'm going to do negative 5 times x, so negative 5x. Then x times 5, so that's 5x. And then 5 times negative 5, which will be negative 25. I can put all that together, put a plus here. Okay. And we'll simplify it. We'll start reducing, we'll start combining things. So negative 5x and positive 5x is a whole lot of 0x. So that's what I said that might be up there. And now we don't actually have to have the 0x, so it's x squared minus 25. This is a difference of squares, y'all. This is a very important special case with quadratics. This is going to graph like this. Ready? Foomp, foomp. And we'll have a negative 5 and a 5 here. So that'll be 5, negative 5. And the y-intercept, when x is 0, will just be negative 25. So let's drag this down a little further. And there'll be, I'm exaggerating the length, that'll be negative 25. And the graph will go up like that. And up like that, something like that. It's kind of wonky and lopsided, but hopefully you get the idea. And so now let's continue. Let's look at x squared minus 24. Perhaps there's a pattern here. It's a difference of squares because that's x squared and that's 12 squared. Okay, so we're reorganizing this as x squared plus 0x minus 144. So what are factors of 144, negative 144, that add up to 0? So we'll do this, do the x thing again. Okay, for some reason the mouse pad is being really crazy there. All right, but I'm just going to ignore that crazy pants stuff that just happened. I'm going to say negative 144. Maybe I can't ignore it completely. And we're going to add it. We're going to add two things. They're going to get to be 0. So I need two factors that make 144. Let me erase some of that shenanigans up here. Okay, we're going to need two factors that make a product of negative 144 and add up to 0. Okay, well, one's going to be negative and one will be positive. And they will be negative 12 and positive 12. And then we can just put an x here and an x here. And we actually have two linear factors, x minus 12 times x plus 12. It's kind of a handy-dandy little organizer for us. Okay, so the factors would be negative 12 and positive 12. Okay, now we're going to expand x minus 12 times x plus 12, which is what we have here. So it should end up here, but let's prove it. We're going to have x times x, so that'll be x squared. You'll have x times 12, so that'll be plus 12x. We'll have negative 12 times x, that'll be negative 12x. And you'll have negative 12 times 12, which will be negative 144. Okay, and we put all that together in the next row. The 12x plus negative 12x will just be plus 0x. That's just a whole lot of nothing. And then we can put that in the next row, and we'll just get rid of that 0. And it's just x squared minus 144, a difference of squares. X squared and 144 are squares. And we're going to consider one more pair of things here. We now are going to look at x squared plus 24x plus 144 instead of a minus. So now we're going to use that nice little handy thing. We've got a product here and a sum here. So we're going to have a product of 144 and a sum of 24. Okay, so we need two factors of 144 that add up to 24. And those two factors would be 12 and 12. So in this case, we're going to have x plus 12 and x plus 12. That's the same factor twice, which means we could just write it once and say it's squared. Because when you multiply something times itself, that's the same as squaring it. So our factors, our two factors are 12 and 12 again. Okay, and so we are going to expand x plus 12 times x plus 12. Let me erase that little extra bit there so we can see what we're talking about. Okay, so we got x plus 12 times x plus 12, and you might predict that it's going to equal x squared plus 24x plus 144, but let's confirm it for sure. X times x will be x squared. X times 12 will be plus 12x. 12 times x will also be plus 12x. And 12 times 12 will be 144. All right, so really I've got a 2 times 12x going on here because there's two of them. And this is just a perfect square structure. A squared plus 2 times a times b plus b squared, where b was 12. So 2 times, well, the x would be the a and the b would be the 12. It doesn't matter, though. They can be in either order. So it'd be 2 times b times a. But so we're getting our x squared and our 12 squared, and we're doing 12 times x times 2. And that is, in fact, a perfect square structure. So we'll have x squared plus 2 times 12x is 24x plus 144. This is a very useful structure to start to recognize. I'm going to keep going on about this over and over again because I really think this is important, and I know where it's going. So please trust me on this. This is important. I hope this was helpful.